We're going to do some interpolation here, and this is just an introduction. It's only scratching the surface. There are whole courses on these techniques, particularly the geostatistics. So this is just to introduce the tools, and it's the barest of introductions. Here I have the states data for the northeastern U.S., and I have this geographic data set, states geography, overlaid on the world topographic and world hillshade. Now, I'm keeping these up while I'm doing the interpolations, but when you go to produce your maps, you probably want to remove the world topographic and world hillshade because it makes it a little futzy. You can get the maps to the extents you want if you include them, but it's just a lot easier if you use them here in the display, and then when you go to produce your maps, you take these two away and just leave the data you're going to produce and the state outlines. So that said, we want to add data from this ozone spreadsheet, ozone.xlsx, and the first sheet that's in there, these are data that I've downloaded from the EPA. And that adds these data here as a standalone table. Now, I can right-click on that and display these as XY data. And I have to identify the X and Y fields. In this case, the X field is going to be the longitude, and the Y field is going to be the latitude. Now, those are in decimal degrees. And the spatial reference is actually an NAD 83 WGS, not a WGS 84, and so I want to make sure that I get the right coordinate system represented, mostly because I don't want to have the shifts that occur when I go between coordinate systems. So the US and its territories, it's the NAD 83 2011. So I go ahead and run that, and it gets the points here. Now, I want to create an output from these that's a permanent data set. This is just a XY data set. So I have to go one step further and right-click on that and come down here to Data Export Features. Now, the Data Export Features is below, which you can see, but you've done this several times before. So I want to use the sheet layer, and I'm going to output that to my my data set here, my geodatabase. Now I'm going to go ahead and run that, and I want to basically create this. And so I now have this L12 PVB. I could rename it or call it something else. So that's a real bona fide layer. I can go ahead and remove then these as I go along just to declutter. And actually, I now then want to change the symbology. So I have these data in here, and I want to make a graduated symbols based on the ozone amount. And the range here makes them a little bit big. I'm going to go these from 2 to maybe 12 or 14, something like that. So I'm making the size proportional to the ozone readings. The bigger the size, the higher the ozone reading over the range here that I set. Now I can change the colors for all of them by clicking on this template and change them to a different color, all of them together, or I can format the symbols by changing the number of classes or the individual breaks between the classes. I'll go with this for now. Now we go through various analysis methods to assign areas associated with these points. These are ozone measurements at point locations, at samplers, but I need to know the ozone, in this case, across the landscape, so I can look at populations that aren't anywhere near a sampler and what their exposure might be. And so there is in this set of tools something called Thiessen polygons, create these Thiessen polygons. And so it's pretty simple. I just use my input features and then I create my output. So I'll just call this output Thiessen polygons. Oops, go away. Here, it doesn't make it easy, does it? And I want to output then the all fields. And I go ahead and run, and now it creates these polygons, and I output all the fields so that when I look at the attribute table, I have the ozone included, so I can color these Thiessen polygons by the ozone level. So again, if I go back to the symbology, and rather than a single symbol, I do graduated colors. I can do the graduated colors based on the ozone from low to high ozone levels. And I can change the number of classes, so I can go to just 3 classes, and I can look at the ozone then here, if I expand this a bit, in my 3 classes. So here I want to do no color, right? Apply for ozone that's less than the value here. It's actually pretty close to the threshold value of 54. And sometimes it doesn't take when you type it. So these are areas that have acceptable levels of ozone. I mean, it gets concerning near the upper end. The real threshold here is at 70. So again, this is very close to the value that I have to worry about. So from less than 54, everything's okay. From 54 to 70, I need to be concerned. Right, so I might give this a yellow value and apply. And then above 70 are areas that are of great concern. So I have this map here with the Thiessen polygons that shows the area that are of concern. Now, I could, if I want to see the actual values underneath it, click on a patch, sure, apply that, and make it semi-transparent. So again, remember, I'll click on a patch here, and then click on the color patch, and in the color properties, click on this bottom one that's the transparency and make those semi-transparent and apply it. So I can see the areas that are in red specifically or in yellow. So here I've done this Thiessen polygon map, and I show the areas then that I'll ascribe based on the nearest measurement point here.